So hello everyone. Today we're going to be doing an interesting trigonometry problem. So namely, for which values of the real parameter m will the equation sine of 3x is equal to m times sine x always have non-trivial real solutions? Okay, so the first thing that I want to do here is find the trivial solutions. And what are the trivial solutions going to be here? Well, we know that sine of 0 is equal to 0, that sine of pi is equal to 0, sine of 2 pi is equal to 0, etc. So we can just rewrite this in the general form that sine of k times pi is equal to 0, where of course k is an integer. And it works for both positive and negative integers. So if we plug in any value of pi times a whole number, or in this case, any value of x, if x is equal to the product of any whole number of any integer and pi, this equation will always have those kinds of solutions. Why? Because then you get the form that sine of 3 times k pi is equal to m times sine of k pi. Since k is an integer, the product of 3 and k must also be an integer. And so this is still the form of sine is equal to sum k times pi, or this will always be equal to 0. M is going to be m, and sine of k pi is still going to be 0. So if you plug in any value of m, of the real parameter m, or any value parameter of m, you're still going to be getting that this is true. So I'm just going to say that x is equal to k pi where k is an integer is a trivial solution. So we're just going to not take this into further account, since we're looking for the real values of m such that this equation has non-trivial real solutions. Okay, now with that in mind, let's go ahead and transform sine of 3x. So sine of 3x can be rewritten as sine of x plus 2x, which is equal to sine of x times, this is the one of the theorems from trigonometry, sine of x times cosine of 2x plus sine of 2x times the cosine of x. Okay, now let's just go ahead and expand these two parts. We're going to be using the double angle formulas. So sine of x times the cosine of 2x is equal to the cosine squared of x minus sine squared of x plus sine of 2x is equal to 2 times sine x times cosine of x, and still times cosine of x from the previous row. Let's go ahead and rewrite this product of two cosines as just cosine squared of x right here, and that is, and now we can rewrite this in a slightly different fashion. Let's notice that we have sine x here and here, so I'm going to factor it out. So we get that sine of x times cosine squared of x minus sine squared of x plus 2 times cosine squared of x. So we're going to get that form, which can further be rewritten as sine of x times 3 cosine squared of x. I just added up these two, and I'm just going to put brackets right here, and minus the sine squared of x can be rewritten as 1 minus cosine squared of x. Okay, so we're going to get that this is the same as sine of x, and when we distribute this minus into the parentheses, we'll get 3 cosine squared x plus cosine squared x minus 1, which is just the same as 4 times cosine squared of x minus 1. Okay, and this is the final form that we're going to be working with. So let's just go ahead and plug this final form into our initial equation, because this final form is just the same as sine of 3x. So we'll get that sine of x times 4 cosine squared of x minus 1 is equal to m times sine x. And we can just go ahead and cancel out the signs. Why? Because we're not including trivial solutions, so x must be different than k times pi, where k is an integer. And so we're going to get that 4 times cosine squared of x minus 1 is equal to m. Or, in other words, cosine squared x is equal to m plus 1 over 4. Notice the possible values of cosine squared x. So cosine squared x can only have the values between 0 and positive 1. And instead of cosine squared x, we can go ahead and plug in m plus 1 over 4, because we got earlier that they're one and the same. Now, since 4 is a positive number, we can multiply everything by 4 without changing the signs of inequality. So 0 must be less than or equal to m plus 1, which must be less than or equal to 4. And now we can just go ahead and subtract 1 from everything. So we'll get that minus 1 is less than or equal to m is less than or equal to 3. So m must be from the interval of minus 1, including minus 1, to 3, including 3. So this is our final answer to this problem. I hope that you understood it. So if n is from the interval minus 1 to 3, including both extreme values, this original equation is always going to have some non-trivial real solutions. And of course, it will always have the trivial solutions regardless of the value of n. So if x is equal to k times pi, m can be any number. It can be any number. Okay, so I hope you enjoyed the video. As always, leave a thumbs up and subscribe. I'll see you in the next one.